Hello, welcome to my channel. We will be doing question number 9 in chapter 16, I will be right. We were doing chapter 16. I was out for a few days. Uh, so, anyway, I believe it was chapter 16. Anyway, okay. So, the question is a particle moves in a straight line so that t second after passing through this point. Okay. We have to have, yes. Okay. It is okay. Yes. So it is given that displacement at any given time is given by 1 plus, oh my God, where is my pen? Okay. 1 plus 3t minus cos of 5t, right? You put the value of t in here and you find the displacement at any given time, at that particular time. Okay. So the first part of this question is that find the distance between the particle's first two positions of instantaneous rest. Okay, so rest means when the speed is zero, when the velocity is zero, right? So if we know the displacement, we can find the velocity by differentiating it, right? Okay, so when I differentiate it, I will get 3 minus the derivative of cos is minus sine 5t and derivative of 5t is 5, right? So this is the speed of this particle at any given time. Now, the particle is at rest when the speed is zero. Okay, so we need to put the speed equal to zero. So 3 plus 5 times sine of 5t is equal to 0. Okay, so it means that sine of 5t is equal to minus 3 over 5, mean minus 0.6. Okay, so 5t would be equal to sine inverse minus 0.6, right? Okay, now if you check this thing in the calculator, you will get the answer. If you're in the degree setting, it is minus 36.87 degree. Okay, now I'm working in the degree, but we have to write this thing in radians. So anyway, there's no problem. We can convert it any time. Remember, but this is negative, right? So it will give me a time which is negative, but time starts from zero. Okay, so the thing is, remember the sine curve, it goes something like this. It goes maximum and then zero and then like this. So this is plus 1 and this minimum value is minus 1, and of course it continues like this, right? So when you're calculating in calculator, it gives this is approximately minus 0.6, right? So calculator is giving you this value is minus 36.87 degrees. Okay, but this is useless for us. For me, important one is this one. When it is first time it become minus 0.6, the sign of this thing. Okay, and the second point is this one. Okay, so these are the 2 points where I want to find the value of this 5t. Okay, now I learned that this minus 36.86 is 36.86 from 0 in this direction, right? So in the same way, uh, from here till here, okay, this distance is 36.87. Okay, so from here you can see this is 180 degree. So I have to add in 180 this value. So my answer would be 5t is equal to 180 plus 36.87. Okay, which will be When I add into 100, yes, I think it is 216.87 degree. You can check with with your calculator that the sine of this much would be minus 0.6. Okay. In the same way, how can I calculate this point? You see, it is, this is again, yes, this distance is again 36.86. So the second answer would be, uh, I should say, yeah, second answer should be 360. From here, it is 360 degree. So 360 minus 36.87. Okay, and this will give you 323.13 degree. Okay, so you can check with your calculator that sine of these two angles will also be minus 0.6. Okay, so from here, if I divide everything by 5, I will get t is equal to 43.37 degree, and the second answer would be 64.63 degree. Okay, and if I convert these into radians, okay, how can I convert into radian? I will have to multiply with pi by 180. So that will give me 0.757 radians. We would C for radian, and 1.128 radians. So these are the two values of t for which the particle is instantaneously stops. Okay, so now the question is find the distance between the particle first two positions. Okay, so distance I can find using the given equation, this equation, right? So let's say S1 is the time when it reach when it stopped for the first time, right? And I can find this S1 distance when t is 0.757. So S1 is um 1 plus 3 times 0.757. Okay. And minus cosine of 5t. Okay. I can, instead of multiplying this by 5, I know that 5t was 216.87. Okay. And you can check that the value of this thing is zero point 0.8. I can talk about it, why is it zero point 0.8 exactly, but let's not get into it right now. And S2 is the distance or position when it stops for the second time. And that we can calculate by using the second value of the time. So 1 plus 3 times 1.128 and minus cosine of 323.13 degree. So the distance between these two instances, let me call it delta S. I will call it S2 minus S1. And these both values are going to be 0.8. So they will cancel with each other, and one will also cancel from here. So the answer, let me write it properly. So 1 plus 3 times 1.128. I think I should make it a little bit thick. Okay. Okay. And minus 0.8. Remember, I told you that this value is 0.8. Similarly, this value is also 0.8. Okay. So this, okay, minus, so this is S2 minus S1. S1 is 1 plus 3 times 0.757 and again minus 0.8. So when I open this bracket, you can see that this one will cancel with this one and minus 0.8 will cancel with minus 0.8. Okay, and this delta S will become 3 times this minus this. I get a 3 times 1.128, and oh, sorry, I made a small mistake. Okay, and minus 0.757. Okay, and this will give you okay. I think I made a mistake here. Minus, sorry. Yes. So the first value would be positive. Yes. Because when I put this value, the cosine of this one, it is positive 0.8. And the second value is negative. So as a result, I will have this thing and yes, minus 1.6. Okay. So this all will be simplified to minus 0.487. Okay. And since you're talking about displacement and that is it should be positive always, so that's why negative sign is not shown in the final answer in the book. Okay. Okay, I hope this is clear. It was a bit confusing question, but I hope you can understand everything. Let me do second part now. Second part is simple. Find the acceleration when time is equal to pi. So what is acceleration? Acceleration is the derivative of the speed. So if I differentiate this part, this expression, so it will give you 0 and then 5. The derivative of sine is cos 5t, and the derivative of this is 5, and this is 25 cos 5t. Right? So acceleration is 25 cos 5t, and we need to find the acceleration when t is this. So acceleration when t is equal to pi. So this is going to be 25 into cosine of 5 pi. Okay, if you remember the cosine curve, it is something like this. It starts on 1, it goes down like this. So this is 0, 90, and 180. So this is basically pi, right? So at pi, it is minus 1. At 3 pi, because this is 2 pi, at 3 pi, it's again minus 1, right? And again, at 5 pi, it's again minus 1. So for every odd value of pi, it is going to be minus 1. So this will make it minus 25 meter per second square. Okay, and this displacement was in meters. Okay, I hope this is all clear. If you have any question, you can always ask me in the comment section. Thank you very much for watching. See you in the next video.